In this lesson, we'll be going over synthesis and decomposition reactions. Let's review. A synthesis reaction involves two simple compounds combining to make a more complex one. And so if we have compound A added to compound B, we would get compound AB. But what about decomposition? Let's say we had our compound AB. Using decomposition, we break down this complex compound into the two simpler compounds that it's made of. So AB decomposes into A plus B. Let's first get into chemical equations for synthesis reactions. Our first question states, aluminum metal reacts with oxygen to form aluminum oxide. Let's dissect this question. Remembering that this is a synthesis question and we are taking compound A and compound B and combining them to make compound AB. Here it looks like we have aluminum and oxygen as our A and B. Adding these together will give us aluminum oxide. With this information, we can make a skeleton of the chemical equation. So what we're going to do is we're going to write out the chemical formula for each compound. So we have aluminum plus oxygen turns into Al2O3, which is aluminum oxide. Now looking at this chemical equation, this is a good start. However, it's missing a few key components. First of all, for chemical equations, we always need to state the states of each compound. These states include solid, liquid, gas, and aqueous. Aqueous just means dissolved in water. And the way that we add these states to each element or compound is we add an S, an L, a G, or an AQ as a subscript. So aluminum, that is a metal, so it is solid. Oxygen is of course a gas, and aluminum oxide is an ionic compound, so we can assume it's a solid. Next, I see something wrong with this oxygen. Just having this O here suggests that there is one oxygen atom present in the equation. However, we must remember that oxygen and a couple of other elements are diatomic. You're probably familiar with the term Brinkelhoff, which is simply an amalgamation of all of the diatomic elements and their chemical symbol. So taking a look, these diatomic elements include bromine, iodine, nitrogen, chlorine, hydrogen, fluorine, and oxygen. What this means is we must always write a 2 subscript because it is diatomic. There are 2. So back to the chemical equation, the proper way to write this would be O2. Now there's just one more thing that we are missing. You should picture every chemical equation as a recipe. Let's say I want to bake a cake of aluminum oxide. We know that we would need 2 aluminums and 3 oxygens. But on my left side of the equation, I only have 1 aluminum and 2 oxygens. So it looks like I need to change the number of how many aluminums and oxygens I have in order to perfect the recipe. Now, seeing as aluminum oxide requires 2 aluminums, the logical thing to do would be to multiply the aluminum by 2. How would we do that? Will we add the 2 as a subscript? This is actually incorrect. We never change the subscript of a compound, but we can, however, put a coefficient in front of the chemical symbol. So simply, we can just put a 2 in front of this aluminum, showing that we have 2 on the left side and 2 on the right side. Now, what about this oxygen? We know that we have 2 on the left side and 3 on the right side. Obviously, if we were to put a 2 coefficient in front of the oxygen, that would make it so that there is 4 oxygens on the left side, but only 3 oxygens on the right side. In these type of situations, the easiest thing to do is to multiply the number of oxygens on the left side by the number of oxygens on the right side. So that would be 2 times 3, meaning that we need to find a way that we can have 6 oxygens on each side. And pretty easily, we can put a 3 in front of this O2 on the left side and a 2 in front of this aluminum oxide on the right side. This way we have 6 oxygens and 6 oxygens. But what about the aluminum? Now that's messed up. We have 4 on the right side, but only 2 on the left side. But pretty easily, we can just erase this 2 coefficient and put a 4. That way, there's now a balanced amount of each element on either side, showing that the recipe is complete with the correct subscript on the oxygen as well as all of the states on the compounds. Let's move on to another question. So here we don't know what the product is yet, All we know is that we have lithium plus nitrogen, and of course nitrogen is another diatomic molecule. Now to find the product of this lithium and nitrogen, we're going to have to use the crisscross method to swap the charges of the lithium and the nitrogen. If you have no idea what I just did, I recommend checking out my lesson on compound nomenclature as something to watch after you finish this video. The link is in the description. So of course we know that lithium has a +1 charge and nitrogen has a -3 charge. Nothing to do with this N2. This is just showing that it is a diatomic molecule and that when present by itself, it must be written as N2, but that does not mean its charge is 2. Its charge is always going to be -3. So doing the crisscross, it shows that we need to have 3 lithiums and 1 nitrogen, showing that the chemical compound for lithium nitride is Li3N. Of course, now we need to add our states. Lithium is a metal, so it's solid. Nitrogen is a gas, and lithium nitride is another ionic compound, so I can assume that it is a solid. Now for the balancing. I can see that we have 2 nitrogens on the left side, but 1 on the right side. So we can multiply the lithium nitride by 2. That way, there are 2 nitrogens on either side. And now for the lithiums, there are 6 on the right side, so we can just put a 6 coefficient in front of the lithium on the left, and this makes it so that the equation is balanced with all of the correct states. So now, what about decomposition? It's pretty easy, it's just the other way around. We have our sodium chloride, which decomposes into sodium and chlorine. Of course, chlorine is also diatomic, so it will have a 2 subscript. Sodium chloride is a solid, as it's an ionic compound. Sodium is solid, and chlorine is a gas. Now to balance this, we can see that there are 2 chlorines on the right side, so we can multiply this sodium chloride on the left by 2, balancing the chlorines. And now, since there are 2 sodiums on the left side, we just have to put a 2 coefficient in front of the sodium on the right side, and this balances the equation. What about carbon tetrachloride? This is made up of carbon and chlorine. Chlorine again having its 2 subscript, as it is a diatomic molecule. Carbon tetrachloride is a liquid, carbon is solid, and chlorine is a gas. And it looks like the only coefficient we need to add is a 2 in front of the Cl2. There are 4 chlorines on either side. If you're feeling confident, you can try these practice questions to help you solving synthesis and decomposition reactions, as well as stating the states and balancing the equations. If you can get these right, I would say you're good with the lesson. The answers will be posted at the end of the video. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.